In this video, we will learn how to convert an octal number to a hexadecimal number. So here we have an example of 75 as an octal number. So the first step is to separate them, separate the digits and write the binary representation of them. So here we have 7 and here we have 5. Now to convert this to the digits to binary, it's pretty simple. You just have to do 1 to 4 and see what digits here add up to 7 and place it 1 below them. So here it's going to be all of them, since 4 plus 2 plus 1 is equal to 7, and for 5 it's going to be 4 and 1 only, and we are not going to use the 2. So we'll place a 0 below the 2 and 1 below the 4 and 1, and now we merge these together, so it will become 1 1 1 1 0 1. Now the next step is to group them in groups of 4 starting from the right. So this is a very important point. So starting from the right, 1 1 0 1 is the first group of 4, and we only have 2 digits left, so we will group them together. And you can just think of the last 2 digits as zeros, doesn't really matter, you'll see why. So now we have 0 0 1 1, the first 4 digits as a group, and then 1 1 0 1 1 1 0 1, yeah. Now once again we need to convert these digits to decimal now, and that is done by doing the following step: 1 2 4 8 and 1 2 4 and 8. So now you see these zeros are nothing, just a placeholder, so you can include them, you can not include, it doesn't really matter. So these digits are going to add up to 3, since there is a 1 below 2 and 1 below 1. And for this part is going to be 8 plus 4 plus 1, which is 13. Now you also need to know the decimal representation in hexadecimal. So from 0 to 9, so let me just quickly write the D. So D stands for decimal and H stands for hexadecimal. So from 0 all the way to 9, they are the same. From 10, 10 represents A in hexadecimal, 11 represents B in hexadecimal, 12 represents C, 13 represents D, 14 represents E, and the last letter is F, which represents 15. Oh, sorry, 15 represents F, and F is the last digit. And also another thing to know is that hexadecimal is a base 16 system, meaning that you have all the digits from 0 to 15, and this digits add up to 16 including 0, of course. So you can never get a number above 16, so last digit is 15, and that's F. So here we have a 3, which is the same. So the answer, let me just erase this now, so 13 was D, so we're just going to leave that here. So 3 is going to stay the same, so I'm just doing this part now, and 13 here was D, and that is the final answer. And you can also write a small subscript of 16 indicating that this is a hexadecimal number, and that's it. So let's do this example now. So it's 3 7 7, separate them first, so 3 7 and 7, and now write the binary representation of these. So it's going to be 1 2 and 4, 1 2 4 1 2 4. So for 3 is going to be 2 and 1, so 1 and 1, and 4 is 0, so you can include that, doesn't really matter since it's a 0 to the left most. Here is going to be all ones. So let's actually change a little bit up, since from the last example I'm going to put a 6 here. So this is going to be 4 and 2 only, and the last one is going to be 0. Now again you need to add all these together and group them of groups of 4 starting from the rightmost. So let me just write these down. Now first 4 groups are going to be 1 1 1 0, next 4 is going to be this part, and the left 0 we can ignore it, so that's there. So now we have 1111 and 1110. This here does not matter. 1111 is going to be 15, and I can even show it that to you. It's going to be 8 plus 4 plus 2 plus 1, and for the other part it's going to be 8 plus 4 plus 2, which is 14. So 15 and 14. Now, as from before, we know that F is the last hexadecimal number and it represents 15, and before F there is E. So the answer, oops, is going to be F E base 16. And if it bothers you, you can always make that table again of 10 is A 11. Even I forget sometimes what the numbers represent in hexadecimal. So 13 is D, 14 is E, and then 15 is F. So that's it. So we have another larger number this time. So you can pause the video and try to do this example yourself. So let's start with it. Let's start with to convert them from octal to binary first. So 2 is gonna be, let me just quickly write that down. 0 1 0. 7 is going to be all ones. 3 is going to be 0 1 1 0 1 1 and 1 1 1. Now you can always write these 4 to 1 again and again, doesn't really matter. And now we need to group them groups of 4. So this is going to be the first group, this is going to be the second group. Oops. Next 4 is going to be the, oops, that's wrong. Oh no, yeah. Next 4 is going to be this, and we only have 3 digits left. So now we again need to convert these to decimal now. So let me just write this quickly again. 1 1 1 1. So 1 2 4 8, 1 2 4 8, 1 2 4 8, 1 2 4. And one more thing that I forgot to mention is that you always need to start from the right. So imagine if you started from the left this time, you will end up with this first 4, this first 4, and then this will be completely wrong because it just doesn't work that way. So let me just redo that. So now you just add these up. So 2 for this part, this is going to be 8 plus 4 plus 2, which is 14. Is it? Yeah. This is going to be 12 13, and this is 15. So it's going to be 2 14 is E, I think. Yeah. And from before E there is D, and 15 is F. So this is the final answer. So if you're able to do this without any problem, then you are a master at converting from octal to hexadecimal. So let's start with this example. There is 5, so I'm going to separate them and write them. 5 3 4 1 4 3 and 0. So 5 is going to be 1, okay, you know what, I'll write above it 1 0 1, and this is going to be 0 1 1. This is going to be 1 0 0 0 0 1 1 0 0. 3 is going to be 0 1 1, and 0 here we cannot skip this since this is a 0 to the right. So here we need to do 0 0 0. We can only skip zeros to the left. So let's say the 0 here, but we can never skip 0 to the right. So that's there, keep that in mind. And if there is 0 between, of course you cannot skip it. And yeah, so now we need to group them groups of 4 starting from the right. So I'm gonna do it right here. So this is the first group. Oops. Yeah, second group, the next group, and then here, and then here, and there's an extra one here. So that extra one is just going to be 1. This is going to be, let me just quickly write that also. 1 2 4 8 is going to be 4 plus 1, which is 5. Next is going to be 8 plus 4, which is 12. This is going to be 1 plus 2, which is 3. It's going to be 1, and this is going to be 8. So now the final answer would be 1, 5, 12 is 10 is A, so B is going to be C, 3, 1, 8. And that's the final answer. Oops, this is going to be 16. And as always, I do have a shortcut method on the calculator for you guys for converting it from any octal number to a hexadecimal number. So I will be making a short video on how to do that on the calculator, and I can give you a brief right now. So go to your menu on the calculator, and you should have a base minus n menu. Click on that, and then click on the oct button on your calculator. It will say OCT in blue color or whatever color, I'm not sure. And once you're there, you can type your number and click on equals to, and then once you've done that, you just need to click on the hex button then. So HEX, and once you do that, it would automatically give you the answer, and you would get this answer. And that's it. Thanks for watching. If you have any questions, you can comment below, and I'll be more than happy to answer them. And stay tuned.